we've been talking about basic probabilities. We looked at some compound probabilities using the contingency tables. Now I want to look at what is considered the complement. And whenever we talk about the complement, this is basically everything except that item. So everything except. Think about if I'm looking at, well, let's first look at the notation for complement. So if we have event A, the complement of event A is A with a C kind of in the exponent area. This is a complement, okay? When we talk about the probability of a complement, that is actually 1 minus the probability that event A happens. Because again, it's everything except event A. And if you recall, all probabilities have to add up to 1. So let's look at what I mean by this. If we look at our sample space for rolling a die, I have a 1, 2, 3, 4, 5, and 6. And I want the probability of 3 complement. So basically what that's saying is I want the probability of 1, 2, 4, 5, and 6. Everything else. Okay? Well, I can do a 1 minus the probability of getting a 3. Well, what's the original probability of getting a 3? It's 1 out of 6. Okay, so 1 minus 1 out of 6 is 5 6, which if you think about it, 1, 2, 3, 4, 5. The reason why we look at the subtraction is because you can't always find just this probability, okay? Sometimes there are too many options, and you're going to lose count of them. So when you want the complement, sometimes it's best to go straight forward to here. Same thing with if you have something that's called at least once. Okay? Let's say that I'm going to flip the coin, and this time I'm going to flip it 3 times. Okay? So we flip a coin 3 times. Now, you pause the video, do a tree diagram, and list out your sample space for flipping a coin 3 times. Go ahead and do so. Pause the video, and then unpause it whenever you've finished. Okay, so you should have gotten that there are 8 different possible outcomes when we flip the coin 3 times. You can get all heads, head, head, tail, head, tails, head, head, tail, 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 head, head, tail, head, tail, 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 head, or all 3 tails. Remember, when you're doing something multiple times, you have to think about taking order into account. So when I look at this and I want the probability of getting at least 1 head. Well, in this case, yeah, I can add those up because at least 1 head it means I could have 3 heads, I could have 2 heads, or I could have 1 head. At least one means 1 or more. So this means 1 or more heads. That's what at least 1 means. It does not mean fewer than 1, it means 1 and more. Now, if I only have 8 options, I can count those up. But what if I have 20 or 30 options? I can't always count them up. So what I can do is, I know that there's only one way that I'm not going to get at least 1 head. It's where I get all tails. So I can do 1 minus 1/8, and 1 minus 1/8 is going to give me 7/8, which 1, 2, 3, 4, 5, 6, 7. I have 7 different outcomes that will give me at least 1 head. So anytime you have that at least once, or you have a complement, do 1 minus the opposite, or 1 minus none. Where you have the probability of at least once, you're going to do 1 minus the probability of none. Okay? That's what you're looking for. So I want you to practice some of the complements, some of the at least once, and then let me know if you have questions.